All right, so what we're going to be doing now is that we're going to be going over something called a natural logarithm, which is a special type of log that has a special base. So like what we've been looking at previously is, log of 7. If it doesn't have anything, it's base 10. And then if we specify if it's anything else, if we want to say, okay, well, I want log of 2, base 2, we specify it. But a natural log is a special one that has actually a base e. So if we ever have base e, log base e, which is Euler's constant, it's a number that's used a lot with exponential growth and decay. PERT, if you remember us doing the continuous compound interest, we use this e. And so if we were to take log to the base e, we would use something called the natural log, which is ln. You'll see on your calculator there's an ln button. And so you go ln x, okay? So that's what a natural log is, and that's what this section is about. It's focused mostly on that. Now the rules and properties of logarithms also apply to natural logs. So here, the number out front becomes its power, so we would have ln 2 to the 5th minus ln 4. And then since we're subtracting, that's division, which would be ln 2 to the 5th all over 4, okay, under one natural log. And then from there we could reduce, in which we end up getting 8 for that one. When we multiply it through and then simplify it, we get natural log of 8. So the next one, the 3 becomes the power, so it looks like we're going to have ln of x cubed times y. And that's going to be our answer for that one. Okay. So the rules and properties of logarithms still apply with natural logs. They don't change. Instead of writing log, we're writing ln. Okay. Now solving, you're going to do the same thing. If you remember when we were doing logs, if it was log base 5 of 7 is equal to x, actually it should be the other way. It should be log of 5x is equal to 7. If we wanted to find that, what we would do is that we'd take both sides to the base. So it'd be 5 to the power of log base 5, 7, and that would be 5 to the 7th. And what happens is that this disappears, leaving us with just x is equal to 5 to the 7th. Okay. Same thing happens here. But with natural log, our base is e, so we take both of them to e. If you take e to the power of a natural log, they disappear, leaving us with just x is equal to e to the 0.1. And then you just type that into your calculator, and you will find what that comes up as. And it comes up as about 1.1052, approximately. And so that's what we have. Okay. So solving these, so the first one, we're going to take both sides of the e, which makes this disappear, leaving us with just 3x minus 9 is equal to e to the 21st. And now we just solve it like it's a normal algebra problem, solving for x. We would add 9 to both sides, giving us 3x is equal to e to the 21st plus 9, and then divide by 3. Divide this whole thing by 3, giving us x is equal to e to the 21st plus 9 all over 3. And then you would calculate that out with your calculator, okay? Which comes out as a huge number in this case. And the reason for that is because the e graph looks something like that, and it grows very quickly. So even if you have, x is only 21, we still see that it's almost billion. It's probably over a billion at 21. So now the next one, we're going to do the same thing, e, and this disappears. And that leaves us with x plus 2 all over 3 is equal to e to the 21st. Multiply both sides by 3, and we just want to get try to get x by itself. So we have x plus 2 is equal to 3e21 minus 2 minus 2, giving us an x is equal to 3e to the 21st minus 2. And that comes up with our answer of approximately 488,292.4 about. Okay. So again, it's just like what we've done before. if we have a number like this where we have an e, okay, let's look at this example. So if I have e to the 3x is equal to 91, let's say. What you're going to do is you're going to take the natural log of both sides. And that drops the power out front, leaving you with 3x, this disappears, is equal to the natural log of 91, and then you solve for x. So you would divide by 3, and that would get you your answer. And then to check your work, you take this answer and you plug it in for the x and see if it comes up with the right number. So like on these, this one and this one, you're going to take the natural log of both sides so that the power can drop. And then the other two, those two, you're going to take it e to the power of e to the power of e to the power of e to the power of. And then round off a couple decimal places, 2, 3 decimal places, whatever it gives you as your answer. Okay, and that's your IRAT. And those are natural logs, and that's the end of our exponential sections with logarithms and natural logs.